Hello, my name is Chelsea Menjivar, and I am a student at State Fair Community College taking physiology. And today I would like to go over an electrocardiogram with you. I will refer to it as an EKG, but it is also known as an ECG for short. So, what is an EKG? An EKG is a recording of the electrical impulses in the heart. These are recorded with the use of leads that attach to our body. I believe the most famous set of leads that are used would be the unipolar chest leads. So these are going to be the 6 leads that attach to our chest. I'm sure they are very popular on the medical drama and TV shows. So in the center, I have a single cardiac cycle EKG. And so that is essentially one heartbeat. The P wave is atrial depolarization, and this is the initial starting sequence for a heartbeat. The QRS wave is ventricle depolarization, and so it's very important that the atrium and the ventricles contract in a coordinated way, because we could run into some issues if they don't. So it's always atria first, ventricles second, and the ventricle depolarization is represented by the QRS wave. Then there is the ST segment, which is the plateau phase. Since this is a recording of electrical impulses, you can think of them as action potentials, I would say. And so this plateau phase would be the heart's refractory period, and therefore we would not see any depolarization in the heart in this ST phase. The T wave is the finishing wave, and it represents the repolarization of the ventricles. And so after that T wave completes, then we can see another heartbeat, and we'll see the P wave that goes to the QRS, and then T. I really like that they were labeled in alphabetical order because it helps me label them in my brain. Just a little side note, there is what I have here would be the heart sounds. And so just after the S wave, there is the S1 or lub of the heart, which is represented by the atrioventricular valves closing. And then there's the S2 or the dub, and that is the semilunar valves closing. And so the ventricles contract and the atrioventricular valves close, and then once they relax, the semilunar valves close. So, fun fact about that. How can it be used? Today I want to cover mainly how it can identify myocardial ischemia and then detect arrhythmias. So to start, myocardial ischemia is represented on an EKG via the ST segment. So if the ST segment is elevated or elongated, that means the refractory period is taking too long and therefore is delaying the next heartbeat. So that can cause issues for a patient. And the next would be detecting arrhythmias. Arrhythmias are just abnormal heart rhythms. So we have sinus bradycardia, which is a heartbeat of less than 60 beats per minute. This isn't always dangerous, especially in those super athletes, but if it gets any lower, it can be dangerous and not getting enough blood throughout the body, especially if it's working so slow. The opposite of sinus bradycardia would be sinus tachycardia, which is when the heartbeat is too fast. Over 100 beats per minute can be concerning, especially if you're at rest. So you'll see a bunch of the series of waves on an electrocardiogram very close together. It'll just look like peaks, peaks, peaks. Next would be when we're losing coordination in the heart. That would be ventricular tachycardia. That's when the ventricles are contracting uncoordinated in respect to the atria, and therefore if the ventricles aren't coordinated, the heart is not pumping effectively, and we're going to see some issues because that can lead to ventricle fibrillation, and that's when there's no coordination at all in the atria conducting nerve impulses and the ventricles conducting nerve impulses. That covers an EKG. Thank you for watching. I will put my resources in the description, and thank you.